Alright, time for another draftphysics.com, debatephysics.com, also video presentation. So photons, and something like a more realistic mechanical explanation for their function, in contrast to conventional physics, which takes it all the way to the point where these things basically don't have a place in the universe. They're just poof from here to there. They, you know, can read each other's minds, so to speak. They're entangled. There are all kinds of bizarre things. And it's all based on an interpretation of a very simple experiment with slits. But it does go all the way back to Maxwell and Thomas Young, which, it's 1801. But it should be noted that these observations were made back in Newton's time. Newton had done the single opening. He had done the single impediment. He just hadn't put the two together, and made a double slit. But he had seen fringes, obviously, and mostly in cases of lenses and all that kind of stuff. So the concept was known. The phenomenon wasn't a surprise, technically. The Young experiment really shouldn't have been that dramatic an event, because everybody already knew this stuff existed, that light did scatter or spread, and do so in an irregular pattern. Well, a regular irregular pattern. It didn't spread evenly across the surface. There were distinct bands or fringes of light. All right, so Maxwell, his math indicates, the relationship that exists between photons and electricity. And clearly there's a relationship between electricity and magnetism. We can create magnetism with electricity. So electromagnetic radiation is sort of made out of coincidental or incidental relationships, and really shouldn't be taken too seriously, as if these phenomenon are elemental. So I would argue that all of them, electricity and magnetism, aren't elemental functions. Nothing elementally is magnetic. It has to be an arrangement of matter to create a dipole, to create the mechanism that's going to make it possible. And that goes all the way back to charge, which I have done a video on, which explains that. Conventional physics has this drawing of a photon. So I have to do this part first, I suppose. It's let's see if I can. Well, anyway, they're saying there's a field going up and down, the electric field, and then a magnetic field. And one's like 1,000,000 times stronger than the other, which doesn't make any sense either. And that somehow, when a photon's traveling this way, that perpendicular, there's some sort of wobbling field that's making the photon do a bunch of other motion or something that has, which you could argue is a vector of momentum, like an angular rotation or some other kind of momentum besides it's just going towards something and it's going to hit it. Now, I would argue the kind of obvious understanding you can have is that, of course, there's a perpendicular relationship between electricity and magnetism. And you can sort of understand that as being just the fact that when something does hit electrons on a surface, that the electrons are all in tension with each other. Now, their model of the atom doesn't say that you could really understand that tension, because the electrons are supposed to be orbiting and spinning and being all over the place. And I would argue that that's all wrong. The electrons are in fixed positions and they jiggle, but they don't fly to other locations unless there is something like electricity happening. So you could sort of understand that if I had an atom and I did hit it, the idea is I'm going to hit the electron. I have to hit some part of the atom that's a real thing. And if I hit an electron here, this way, I'm going to push the electrons here and here that way. So that's the perpendicular relationship. And once you understand that, okay, so energy comes in this way and it produces energy going this way, that's electricity. And the real key to it is that it's basically a tipping point argument. To put enough pressure to get some velocity, you hit one electron, that pushes an electron that way, and then you hit this one, and that pushes it even faster, and then you hit this one, and that pushes it even faster. Now it can jump from atom to atom, and now you have electricity. So you can sort of understand that electricity is built out of a sequence of events, and it's sort of like a tipping point argument. You have to hit the atom, the first atom, cause motion, and then you have to hit again before this electron goes back to its original condition. You have to hit it while it's still going that way to add velocity. Once it's going back the other way, you're not going to be able to add anything. You're just going to end up with a net product that's less than what you started with. So you have to add the energy while the other electron is still going in that direction, and then you can tip it over. So if you hit something and you allow it to wobble back, you can't tip it over. But if you keep hitting it before it can bounce back, things in tension, things that are elastic. And the argument is that atoms are elastic. And so that's how you create a photon. It's really just a sequence of events. So I guess I will redraw this. It's sort of necessary to understand. You don't have to accept their understanding of the mechanics of a photon, and that this different mechanics makes it understandable about how photons are affected and how you make one, break one, and then remake one. Alright, conventional physics doesn't really give you any description of how photons are shaped or sized or much. And there's a little insight in Einstein's photoelectric paper where he talks of light quanta or quantas of energy. And so the idea is that a photon really is just momentum, and it can be understood that it's an event in space and time. So it should be something that Einstein would have gotten right. And that the frequency isn't some hump or some field change or something. It's an actual thing, a bit of force. Okay, and the bits of force have a distance between them, and that's their frequency. And so they're going to hit a surface at a rate, and the rate has to be consistent if it's going to, as I just explained, add energy to a series of atoms. Now, what we know about photons is they have a rather large polarization. So the idea of polarization really is illustrated best by antennas, and understanding how an antenna works in terms of producing photons is that it's as the electricity moves up and down the antenna, that is, the voltage change jiggles the antenna, the AC current. What's going to happen is you're going to be basically sending a bit of energy from a location, and then at the speed of light going up the antenna is when each atom's going to get disturbed by the electricity that is going to pass an electron, which means it's going to change its shape essentially, which means it's going to reflect the universe differently. And the point is the electrons are basically just pushing out of the surface of the antenna. And when they push out, they push into a field of pressure energy, and they change the frequency of that energy coming in. They reflect it different. But the point is they leave at a different rate. So this one would be here when this one leaves, and this one would be here when this one leaves. And so they'd all end up in a series parallel to each other, traveling in the same direction, and that's the polarization. So the distance this between them is the frequency, and the distance this way is the polarization. So they could be polarized in any plane depending on where your antenna is. And with light, there's no antenna, so they're polarized in all directions. Generally speaking, there's no antenna. And such. So with that understanding, our background, then we can do this double slit experiment. All right, so these are all observations over the last 10 or 12 years. This is how I got started doing any thinking, serious thinking about physics, is what they were saying about these experiments just really was so nonsensical. In terms of a single photon going through both slits, I mean, the photons are much smaller than the distances of the slits, and it just doesn't make any sense at all. Even theories where they go through and then they stop and they go back through the other slit. I mean, just all kinds of crazy stuff. Photons interfering with themselves. And then you get into entanglement and it gets even more bizarre, and you're saying that just can't be the right answer. And I would argue that that's Einstein's reaction, is that it just can't be the right answer. It's just too wooey, too messy, too weird, too crazy, too ridiculous. All right, and so through the years, the obvious has become apparent, and stuff I should have known. Now, from the very beginning, I said this has to be about the surfaces. The surfaces are the only thing that you're changing. So one of the first things that became sort of apparent is that you can have an open slit or you can have an impediment. And you'll get two very similar patterns, indicating it's not about light going through an opening. It's about these surfaces. All right. So the single slit is really the two surface experiment, and then the double slit is really the four surface experiment. And then this is verified by their own math. Now, this took me a while to realize, but it was just so obvious that their math is all about this distance between the surfaces, and they're really just drawing vectors between the two surfaces. So they're just acknowledging that these are basically point sources. The surfaces are point sources, and there's a certain number of places where I can have a wavelength of difference. And the only reason why the wavelength of difference matters is because of the phase change. So you could argue again, if you want to disturb these atoms correctly to make electricity, they have to be disturbed in this proper sequence. They have to be hit at the right time to add energy. It's the tipping point argument. And if they're out of phase, that's the same as having the wrong frequency, and it won't work. And this also comes up in radio experiments where you can just jam a signal because you have two signals competing to initialize an oscillator. And the oscillator can't initialize on two signals that start at different times. It can't tick-tock if one's going tick-tock and the other one's going tock-tick. Okay, yeah. So anyway, so the math is a huge giveaway. The math that actually works actually just deals with distances between surfaces. It's not about the opening, it's about the distance between the surfaces. So that's why these two experiments have the same output, except in terms of the intensity of the light. It's because the surfaces are they can be the same distance, and they'll create the same proportions in the pattern. So the single slit has this characteristic appearance. Now this could be 70 or 80 of these fringes, and they diminish in intensity. Okay, so they get weaker and weaker, the same size. They actually get bigger as you go further out, but we can't really see that because they run out of photons. And now theoretically, if this was a wave phenomenon, if this really was about some waves coming out, it should be just as intense over here as it is here, and it clearly isn't. And often what they'll do is restrict the slit so narrow that there is no wavelength of difference between the two surfaces. That is, the 2 point sources are so close that you can't draw 2 lines from those 2 points. They'll end up a wavelength different because you have a base to the triangle that's too small, smaller than the wavelength. So you can't make 2 lines that are longer than a wavelength, one longer than a wavelength. So you get none of this. You get no place where you could possibly have them out of phase, because they can't create an out of phase, a complete one wavelength out of phase interaction, to create the next node. So the truth is that whatever number of wavelengths fit in this distance between the surfaces, so if it was 10 wavelengths, then there would be 10 of these nodes going to the left and 10 going to the right. So it basically tells you the answer to how many of these little nodes you'll get. And so they always display this on a flat surface, sort of implying that it's an infinite pattern. But if you really put it on an arc, equidistant, the way the math is predicting, you can see that it's a finite pattern. There's a finite number of locations, and it's just dictated by how many wavelengths fit in that base. So 1 wavelength fit in the base, 1 fringe. 2 wavelengths, 2 fringes. 3, 4, 5, just goes on like that. So that's a huge giveaway that this is all about surfaces, and it has nothing to do with any kind of wave going through the opening. It's not water. Okay. Now, the other giveaway is the fact that you have a double maxima here in the center that conventional physics doesn't explain. And it's always, when you do the double slit and you see both patterns, you'll see that it's always an odd number in the center, which basically means there's a 3 and a 3 overlapping. So if you could understand that the fringes were 3 of these little dots, you could understand that if I overlapped one of them, I'd end up with an odd number. And you will every single time it works. So the center double maxima in the double slit experiment is always an odd number. 1, 3, 5, 7, 9, 11, blah, blah, blah. And so another giveaway that this is some sort of mechanical cause. Now what becomes obvious is that you really are creating 2 patterns. When you bring 2 single slits together, let's say if I slid this single slit into this single slit, I haven't just put 2 single slits together, I've brought in 2 surfaces at completely new locations. Okay. So where I had 2 surfaces just separated by this distance, okay, and I had this separation of this distance, when I bring the 2 together, I have this new distance here. And this new distance is huge. And that's what's creating all of these nodes, because it's a huge difference. There's a huge number of wavelengths that fit in here, and that's creating the little dots. So the size of the little dots you'll see is completely determined by this outside dimension, and the envelope, as they call it, pattern, will be decided by the smaller separation, either the central impediment, the distance between these 2 surfaces, or the distance between this one and this one. But they're always usually related anyway. And that completely explains the 2 patterns, which conventional physics has no explanation for, provides nothing. Now what they do is they call an experiment a double slit experiment, where they make the slits infinitesimally small. So again, just as I pointed out before, if you put 2 surfaces really close to each other, they can't produce a wavelength of difference. So you basically just wipe out the envelope pattern. So you can't have an envelope pattern anymore because you've wiped it out. You've wiped out the mechanism that was creating it, and all you have is this distance. Essentially, you have the outside dimension. because you don't have these surfaces are so close to these other surfaces that they can't make a wavelength of difference. So you just basically are saying you're doing an experiment and you might as well just calculate from the middle. It doesn't matter because it's such a small difference between the 2 points. So you go from having a 4 source experiment to having, because 2 of the dots are so close together, it ends up being a 2 source experiment. So you end up with a pattern that'll look similar to the single slit, except there won't be any double maxima, and you'll just have dots. So it all works. It predicts the patterns you see. It explains the patterns you see. And I will explain now what causes it and such. Alright, so you understand a universe where matter, okay, isn't, this doesn't have a smooth surface. It's covered in atoms, and the atoms are covered in electrons. So on any surface, you could understand there has to be, yeah, I'll draw blue for electrons, which they have wrong, by the way. The electron should be the positive element, not the negative element, because the electrons are what you can add and subtract from an atom. So this is the surface, okay, and it's covered with, say, atoms. So we'll draw these a little bit uneven, but these would be the net positive nucleuses here, okay, and you have atoms on the surface. Now you can understand that if this universe is full of energy, cell phone calls, radiation from stars, all kinds of energy is in the universe. It's very warm, okay, lots of little bits moving into things constantly. You can understand that everything's being constantly jostled. And the only place that can be reflected is on the surface. So you could understand that all the jostling that's going on inside the material, the electrons are basically going to move out, perpendicular to the surface. So they're going to be jiggling. They're not going to jiggle into each other, in other words, into the force. So if they're arranged, and they're sort of equidistant, they could be arranged this way or this way, they're not going to go this way in towards each other. They're always going to try to evade each other. So they're going to be moving in and out of the surface. All right. So that's their motion, that you're going to be passing your photon through this gauntlet of electrons doing this back and forth. Now, the photon, as stated, is these this pattern of energy. I can't draw the polarization in this example, but you could just understand the photon's going to pass through that gauntlet. So the photons that go near the surface are the only photons affected. They're the only ones that create fringe light. The photons that can get through the middle go straight through the middle. Now you see that in the pattern, because if you ever did this experiment, you would notice that the center maxima in the slit, where you have open slits, is intensely bright. Professor Lewin says it's 97% of the photons. I think might be 93. So we'll go with 93. 93% of the photons hit the center, and only 7% is all of the fringe light. Now it might be 4%, it might be, so it's a huge difference. So with open slits, most of the light just goes straight through, and it just, what you see is pretty much just a tiny bit of spreading that you can expect, because the photons are never perfectly coherent going in. They all have a little slight angles, and so you end up with a huge amount of light, so much light that it ruins the pattern sometimes, where you can't even see the fringe light because this is so bright. So another clear giveaway, this isn't about a wave. Waves don't create 97% of the wave hitting here and only 1% hitting here. Waves don't do that. Alright, so anyway, so here's your photon. This is one that's going to be near the surface, and what's basically going to happen is it's going to have this random chance thing that's going to happen. Each bit is going through the gauntlet, and it could just pass right through without hitting an electron. And the second bit Now it could go through and it hits this electron, and this electron just happens to be going that way. It's going to change the direction of the electron. The momentum this way with the photon is going to combine with the momentum of the electron this way, and you're going to get something going this way, some percentage. Now when that electron moves that way, what it's going to end up doing is producing energy in that direction. So you're going to have a tendency, okay, to deflect the light. And the truth is that the pattern, tends to be, obviously this side is producing photons pieces this way more than it produces that way. And that could be the argument why the pattern diminishes with distance, is because it can't evenly go through the material. The energy can't go through the matter, the ones deflected in towards the surface. So you understand some, but clearly on this surface they can. So once they get to this outside, they hit an electron here, they can definitely be pushed in that direction. And if they hit two electrons moving in that direction, they're going to be pushed even more. And so what you're basically doing is that from the two surfaces, you're taking the bits that come in, okay, that have a pattern, and you're basically breaking the pattern in the sense that some of the bits are going to go, that bit will go this way, this bit will go that way, this bit will go that way too. And they're basically just scattering like little point sources. There's little BBs flying off from both of these surfaces. And all you're really saying, and the math is directly saying it, so the math validates this perfectly, is that the lights can only go these two ways because the surfaces are perpendicular, so you're always going to end up moving the light in those two directions. The light's not going to go this way or that way. Now you can see if you do the pattern on a rough surface, you will get pattern going up and pattern going down because you are changing angles. And if you use round apertures, you'll get rings of fringes. Exactly the same fringes, exactly the same proportional distances. It'll just be a complete ring because you're doing a whole bunch of slit experiments essentially in every single radian of all the degrees. So anyway, and so all you're doing is basically saying you're going to take these bits that were in sequence and you're just going to scatter them onto the surface. And the truth is, when they hit the surface, all you want them to do is hit the surface in the right pattern. That is, with the right time and the right distance between when they hit. And that'll create the photon. That'll create the electricity. So it has to hit dot, dot, dot. And the simple truth is it's a 50-50 deal. 50% of the time they're going to be going in phase, and 50% of the time they'll be going out of phase. Some measure of going in or going out of phase. And that's what's creating the fringe pattern, is you're merely putting the photons you broke back together. So essentially the slits break the photon, the phase, and all you end up doing is putting the phase back together. So a piece from over here and a piece from over here reconstruct the sequence. So if this piece was missing, that one was missing when it went through this side, and the other side, the other surface, produced this one. And so now it's a photon again. Now it has the right timing again. It's got its frequency back. So now it's a photon. Now it can properly add energy to an electron and create enough momentum to create electricity, to create the electron jumping from atom to atom. So this particle model perfectly does explain. They claim that no particle model can explain, but it does perfectly explain, and it resolves issues that physics doesn't explain. It doesn't explain this huge amount of light going straight through when they're supposed to be waves, and waves are supposed to be even everywhere they go. So it doesn't duplicate waves at all. Again, the math is just straight line vectors, and it's either in phase or out of phase. It has nothing to do with destructive interference or constructive. No photon, no bit is hitting another bit in space here. Now I can use another experiment to prove that, but I mean that's not what's happening. There's not little bits of energy hitting each other and combining or destroying or any of that. It's just merely saying you have stuff moving at frequencies, and the fact is you're going to disturb some of it and then spread it. And that's what you're doing. The fringes are all this spread light. They're light that is now going to travel a different path than it was originally traveling. The little bit of energy was going straight, and now you've deflected it into some angle. So it's really just, they're both just diffraction experiments created by the energy on surfaces. And you're just really talking about putting them back in phase again. So putting things back in phase is not a magical event. It doesn't have anything to do with a constructive anything. It just has to do with the fact that you're now hitting the surface at the right sequence. And that's about it. See if there's anything. I don't think there's anything I can do with this drawing. Alright, so we'll move on to the other photon experiments that kind of prove the case even further. Alright, let's do polarizing film first. Okay, so a polarizer is basically a material with one layer, and you put little stripes of a second layer on top. Okay, I don't know whether you can see that very well. Running out of ink, I guess. And so you have a place where there's one layer, and then places where there's two layers. And what basically happens is that each layer creates a half wavelength shift in the polarization. And because each layer, the light goes a little bit slower through the material, okay, and so it's delayed. So that's the same thing as changing the phase. So if I had two photons that start at the same time and I put one through the material, it ends up now the two of them will be in sequence, a sequence. So basically you take this polarizer, as it's called, and you can take two of them, and you can have these stripes in opposite directions, and you will block any light you try to transmit through both of them. No light will get through. Now it's not because this one absorbed any photons, or that this one absorbed. They're almost transparent. They're, you know, translucent anyway. So they're not absorbing photons. They're not killing them. They're not using them. They're not getting hot. Okay. And the simple truth is, though, you've got no photons. So all of the energy of the photons is apparently not getting through. And the argument I would make is, yes, it is. It's just that all the photons now don't have a coherent frequency and polarization. So either their polarization has been broken or their frequency has been broken. So they're now in little pieces. And you've guaranteed it by essentially having these films in two different directions. You're basically taking, in one case, you're changing the phase this way out of the polarization. In the other case, you're breaking the frequency by changing the location. And the simple truth is you put another filter in diagonally, alright, and recover with some percentage, 25% or so of the light. So clearly these two filters weren't destroying the photons, because I can remake them. I can stick this other filter in and I can stop them from disturbing the photons in whatever way they were disturbed by the first filter to some degree, and recover the photons. So it's sort of an indication that the photons were never destroyed, they're just broken. Okay? They didn't disappear. They're not unphoton. They're not unenergy. The energy got through the polarizer. It's just not in a form that's going to create a visible photon. That is, it's not going to create electricity in an eyeball and on some surface. It's not going to do what's necessary for us to say a photon hit. And in most cases, for us to say a photon hit, we need to measure the electrical potential, or we need to see the photon actually bounce off the surface. We need to see a new photon created, in other words. Alright, so that's probably enough of that. Alright, so the radio and radar type experiments where they use photons to do similar slit style experiments, but they're really not the same kind of experiment, because in these cases with radio and with radar, the tuner, the thing detecting the signal, is the key, because it can only, again as stated, it can't tune two different signals. So if two signals come in and they have the same phase, that is, they're in alignment with each other and the same frequency, it can tune both of them in. But it can add one song to another song, for example. But if they're out of phase, okay, then the tuner can't see either one. It's basically going to see this higher frequency. It's going to see a signal. It's not going to be able to pull out of that the fact that there's two separate signals. It's going to see twice the frequency, and it's not going to be able to say, okay, that signal has two signals built into it. It's not going to be able to extract either one. So it's not going to resonate at that. It's not going to be, you can't tune it in. So these are just jamming experiments. Now they do have the same visual look, but they're just jamming experiments. And you can clearly see this with the antennas, radio antennas. So if I have two signals, they're in phase, and I send them from opposite directions, so they can't entangle, they can't constructively and destructively do anything. And I can just move a receiving antenna between the two, or I can just move one of these antennas and I will create on, off, on, off, on, off. So I'll create a fringe type pattern. But all the pattern's really saying is that these phases will change when I move the antenna. So if I have two signals coming and they have the same period, and then I move the antenna 1/2 wavelength, now they're doing this. They're superimposed on each other. I can't receive either one. And then when I get them back in phase again, I can receive both. And then when they're back in phase, I see, and that's all you're seeing. So you're just seeing a jamming experiment, frankly. One radio signal is jamming the other when their signals are out of phase. And that's the simple truth. And so the same thing, you can do the same thing with the radio. You can put two sources and a receiver, and then move the receiver in the field, and you'll get on and off and on and off and on and off. And it's exactly for the same reason, because these vectors will be, one of the vectors will be in phase or be out of phase, in phase, out of phase, in phase, out of phase. And that's all you're doing. You're just making phase changes, and when they're competing, that is, when they're both sending the same frequency but at different phases, the receiver can't decipher it. It doesn't see it. Again, if if I double the frequency, the receiver just, like I said, I can, it can't say, oh, there's two of these in there. There's this, and then there's this, and this. The receiver can't extract one signal from the other signal. Just, not possible. This is a side note. I did notice just now, when I have this other light on, you can see it makes the image disappear. So if I do it this way, you can see that little arc of light. And whatever's where that arc of light is disappears. So it's just something to understand about this idea of constructive. Light plus light equals dark, or light plus light doesn't equal a resolvable end product. And it should be recognized that there's lots of things that trick us, but they're not real. That we're being fooled, by what looks apparent, but underneath it's not what's really happening. Alright, so back to the slit experiment. So I'm going to just draw it in this crude manner where just the surfaces are just so we were just acknowledging what's really happening here. And the simple argument is these two surfaces, if I was just to isolate them and say those were the only two surfaces, alright, they're going to do this from one source to another source. So if I had these two sources producing red and blue light, you could argue that these would be points where it would be purple and it would still be red or blue in these other locations. Well, anyway, so these surfaces create the the envelope pattern, and that there's photons in all of those locations. And and the only place, these places, there's no visible photons here or here or here. And then the two outside slits are creating these dots. Okay. 5. All right. And there's no photon here because that's an out of phase. And then there's another dot here, and another dot here, another dot here. And so there's no place where there's no photon. There is actually a dot here, and you can actually see it. Alright, if you do the experiment carefully, you can actually see that there's a little faint dot in this dark spot. So it's not like there was no light getting there. It's just that there's not two sources. Both sources aren't contributing. So when only one source contributes, it's very faint. And when both sources are contributing, it's brighter. Okay. So there wasn't like there's any place where there's light plus light equals a dark. And the fact is that what messes the experiment up in terms of what they often don't account for in doing the experiment is that when you have more light, you change the exposure on the camera. So if the camera is automatically adjusting the exposure based on how many photons are hitting the surface, they're obviously going to make, as this gets brighter, this little dull spot is going to get darker and darker and darker as this gets brighter. So you're going to lose the sight of it because your camera is going to compensate for this being too bright here, and it's going to say we need less light coming into the camera. It's going to squeeze down the number of photons to get into the camera, and so you won't see this faint one. But if it keeps the exposure open or the same, ideally, you'll see that yes, there's a faint dot here. It's there. All right, and you're just saying that this is a spot where it's only two surfaces are making a contribution, and all of the dark spots between the little dots is where there's only the one source from the close slits making a contribution. And it's where all four surfaces, that's where the dots are. So when you see the end pattern of the double slit, it's just made out of dots. All right. And all you're saying is that there's places where only one source is affecting it. And you can see where both sources are out of phase. That's this. Well, like, you can't say both sources. Again, the small one is there. So I misspoke. But it's just a 50-50 thing. So the dark spots between the dots are where there's only one source making a contribution. And in the case of the other pattern, so where you see the dark, it's neither one is in phase. Neither one is creating a photon in phase, and that's where the hard darks are. So I should have said that better. So the places that look really dark, it's because neither source is producing an in phase at that location. So even the envelope pattern has a dark spot, and it's the same as this. This has a dark spot in the same location. So wherever the same locations. So you can see this more dramatically when you do a multiple slits. So when you have a diffraction gradient or you use multiple slits, you'll end up just getting a pattern that's round dots separated by greater and greater amounts of distance. And all you're really doing is saying there's only certain locations where all of these sources, every single source, is in phase. And then every single source is in phase here, and then every single source is in phase here. And that happens less and less frequently per linear space the more of these lines you have. So the more lines you add, the more surfaces, the further and further and further apart in phase, all in phase, becomes. And it's pretty simple. And you also end up casting images. So instead of just pieces of photon light being reconstructed, you actually can transmit an image to these different locations. So I could put a star, image of a star in, and I can get images of that star, okay, in all of those locations, because they're all contributing to each one of those locations. So they're basically taking all of the information that was in the photons that went by that surface, and they're sending it to that location. If you added up all those images, you'd end up with one bright image that would equal the number of photons that went in the first place. Alright, so you haven't destroyed anything, you haven't done anything constructive or destructive. All you're doing is modifying phase changes. Alright, with distance changes. Alright, I think summing up. So the experiment really should always be understood. It should be viewed with an equidistant target. Okay, so it should be viewed on a round surface. And what will be noticed is the nodes do get bigger, okay, as they go from the center to the outside. They'll increase in size. And the exact number, again, will be exactly the wavelength number. So the number of wavelengths that fit between the surface will decide how many of these little nodes there are going to be. Always works. Because all you're really doing, okay, you could understand that you're just taking two surfaces with two different distances. And this distance, okay, let's say that distance was 14.5 wavelengths. Well, then you would know that at this 90-degree angle, or 0-degree angle, that this would have to be an off. And so that your pattern would have to be, essentially this dictates where your pattern starts. So understand, they do this stupid thing where they say, they draw equidistant line from here to here. And they'll say, see, it's the same. These two lines have to be, this has to be an on. But the truth is that's happening inside of less than 1 millimeter. This experiment less than 1 millimeter. And on the target, that spot is on something. This node might be 6 or 7 inches across. I mean, it's a huge distance. So obviously that 1 millimeter is not relevant to the real pattern. The real pattern is created by these lines, the lines going in the same direction. Lines going in opposite directions are inside of less than a millimeter. The lines going in are inside less than a millimeter. They're not creating the fringe pattern. These lines going in the same direction are creating the fringe pattern. So that really needs to be understood. So the one that really decides where the pattern starts is this. So if it was clearly just 14 wavelengths, then we know this is an on. So we know this is where the pattern starts, and then it goes up through here. And the real point is that you're just deciding how much overlap you're going to have here. So if so, it overlaps a little or overlaps a lot. In terms of you have the 3 nodes, and they could be a little bit off, and this is what you end up with. So you end up with your odd number. and you have a lot of very little overlap, or they overlap, more completely, and so it'll take up a little less. So it's going to be somewhere around twice the size, but it could be a little less than twice the size or a little more than twice the size, depending on how much overlap there is. So not really important, but just to understand, that's what the central maxima is just showing you, is that there's two sources, and so there's two experiments essentially. There's this experiment going this way, and there's this experiment going this way, because this stuff going through the middle is irrelevant. That's only a millimeter, so that doesn't mean anything. So it's really just these two sources, okay, one's where the lines are going that way and one's where the lines are going that way. So there's just two really experiments, and the two experiments are essentially just overlapping in the middle. Alright, so I think that's probably all you need, but I'll see if there's something else to throw in. Yeah, I think I'll just reiterate a point. So the argument is that electrons and protons are in the real universe. They're the things, the elemental bits, and they produce everything. Charge, magnetism, electricity, everything's created by the movement of electrons and protons. They're the machinery, and they're in this field of this stuff moving the speed of light. And when the stuff moving the speed of light hits the electrons and protons, it moves them. Now, you can make the simple argument that when it's moving them, it's going less than the speed of light, therefore sort of degrading the force, and that could be the cause of gravity. So you can understand that if electrons and protons are jiggling, they're using energy to do that. And so whatever has electrons and protons in it and they're jiggling, it's creating gravity, because more energy is going in than's coming out. And then the whole idea of charge I did the video on, so I won't re-explain the simple 2 plus 2 plus 3 physics. So you have two kinds of force, electron force, proton force. You have two kinds of elemental matter, electrons and protons, and basically three interactions. You can push an electron, you can have energy stick to it and move it. You can have energy reflect off of it if the electron's already moving, or you can have proton force go into an electron and come out electron force, so the force changes its character. So those are the three interactions, and that creates repulsion between electrons, attraction between electrons and protons, and basically creates both electricity and magnetic monopoles. So photons are in the energy, and the idea is every time an electron moves, it compresses the force that was moving towards it. So if the hand stays here, the photons hit and they bounce, and so they keep the same frequency, right? So if two of them are coming in, one and then two, they leave with the same frequency. But if my hand moves while that's happening, then the frequency is going to get shortened, right? It's simple. First one hits, second one hits, now they're really close to each other. So you can understand you compress the field when an electron moves into it, and then when an electron is moving away from it, the exact opposite happens. The first one hits here, and the second one doesn't reflect till way back here. So now the frequency's been expanded. And so electrons moving on surfaces are constantly creating what we detect as infrared radiation. And every time you can get those electrons to move at some other rate, you'll create some other kind of photon. And obviously getting them to move very quickly, okay, can create ultraviolet light or X-rays or other kinds of photons. And I would also say, obviously, it's harder to get them to move quickly than it is to get them to move slowly. So it's easy to create radio and microwaves and infrared, and it's a lot harder to create ultraviolet and X-rays and gamma rays. The tighter the frequency, the more energy had to be in the system, the more vibration speed the electrons had to have. And more vibration speed implies more momentum, which means it's going to be more fragile. It's a more breakable system if it's vibrating at a high speed. So it's a more rare event, is the simple explanation. But clearly, that's all it's about. It's about frequency, phase, and polarization. And those concepts don't have anything to do with any kind of wave duality theory. And there's just no reason to believe forces can affect forces and that they interact with each other at all, because there's just no corroborating evidence showing it ever happens. So any theory that speculates that a force is interacting with a force should be suspect and should require rather dramatic proof, not supposition. Just and poor, not even really connected supposition. Again, they never overtly state that there's only a certain number of these fringes, and the number of fringes is completely dictated by how many wavelengths of distance there are between the surfaces. It's clearly a phenomenon being created by photons interacting with surfaces. All right, so enough said. So I'll just make the general statement that it's very disappointing that reasonable people will not react reasonably. Okay, people who think they're reasonable, scientific types, show me types, they just don't care. They have this faith in this wooey garbage that's been fed them for the last 100 years, and that's all it is. It's just 5 people, 10 people decided what you're going to believe. These mullahs of the religion. Bohr, Einstein, Heisenberg, Schrodinger, whatever. 10 people who are telling you what the truth is, and they're just telling you, and they really aren't showing you with hard evidence. And in the case of this double slit experiment, the mysticism, they can't come close to drawing it accurately. I mean, Feynman just uses a squiggly line. These are really set patterns produced. The pattern the single slit produces is very different than the pattern the double slit produces. Distinct features, and they ignore all of it because they're selling a fable, a story, and that story doesn't have any explanation for those distinct features. And that's the truth of it. They don't give you any description of what this photon is. I mean, can you imagine a 10 mile? I mean, there's radio waves that have a frequency that's essentially 10 miles at the speed of light between the nodes of the frequency. So you can say, I kind of understand if I was going to argue, I could throw a rock, and I could throw a rock 10 minutes later in space, and I ended up rocks in space that had a very long frequency, long wavelength, and they were going to hit a surface. Now that's a clearly easy to understand mechanical system creating a frequency. They're going to land, and if I threw them from the space station at the moon, they're going to land on the moon and they're going to hit in sequence, and it all is going to make a lot of sense. But what sense can you make out of some field purple blob thingy where the field is what? It doesn't make any sense. What is a photon then? Is the photon actually one big giant jellyfish or something? What the hell is it? You can't make any sense out of it. And understanding it as a particle theory is infinitely more reasonable. And I just don't understand how your resistance to accepting that, yes, come on, the facts point to it. It's a surface phenomenon, and it's just about frequency and phase, and it's not about wooey wave thingies. So I can only do my part here, and your resistance is evidence of that we really haven't advanced much as thinking people, because people just don't really care about the truth. And the fact is the truth you believe in is suspect. And instead of dealing with that and making some kind of reasoned counter arguments, you just run away from your obligation to counter argue, which you can't do because the facts are just so obvious. Everything I said in this video is true. I mean, I might have made some verbal mistake somewhere, but I'm just saying I might call it proton and electron. But I'm just saying it's all true. The patterns are distinctly different. It is true that it's better to view it on an arc surface. It is true that the nodes get bigger as you go to the 0 point. It is true that this will have to be this. It is true that they've never even tested. So, in all these years, they talked about the mystique of the double slit experiment, and what they've never done is put photographic film on either side. So they'll detect photons here, but they'll never try to detect them here or here. And the reason why is because guess what? They're not there. Because you don't bend light that much. The light only gets bent a certain amount by the electrons, and that's it. It doesn't get bent 90 degrees. So there's not going to be any photons here. There's not going to be any fringes here, because photons just aren't going to do that 0 degree angle thing. Just ain't going to happen. But if their wave theory were true, it should happen. But why haven't they done that simple test? Put detectors over here and see what happens. See if you collect any photons. Never done the experiment. Alright, so till the next time and such and so forth and whatnot. It's all quite disappointing. But like I said, it's a commentary on the nature of human beings, that even people who are supposed to be above being petty fascist propagandizing fabulists, they are. Science is just as much a religion as religion, unfortunately.